Welcome to MAT 111 Algebra 2. This is the Chapter R notes. We're on Chapter R.2. You can read this section and go through all the specifics. It's from page 13 to 18, but I'm going to give you my take on operations on real numbers. So we basically have addition and subtraction, and sometimes we call these combine, and we also have signed numbers, those integers that we talked about. And then we'll call that number 1 because that's where we start. And 2, multiplication and division. So let's take a look at real numbers. So here's my take. There's only 2 operations. There's only 2 operations. Addition is weak. Multiplication is strong. What happened to subtraction and division? Well, subtraction is addition of the opposite. And what is division? Division is multiplication of the reciprocal. There's only 2 operations, addition and multiplication. Actually, multiplication is repeated addition. So really there's only addition. You can do everything with addition. But you need to know your sign numbers, your integers, and you need to know your reciprocals, which flip. Those are fractions. Those are fractions. So you need to know all real numbers in order to do this. Do you need to know irrational numbers? No, you really just need to know the rational numbers in order to do operations on rational numbers, which includes decimals and fractions. Yeah, and the sign numbers. That's my take on it. So let's just take a look at adding and subtracting, aka, so let's look at level 1. Level 1, addition. And okay, I'll say subtraction. Well, I said it was weak. We need like, well, weak, like, I guess we could say like denominators we've heard of. Like denominators when we add fractions or subtract fractions. We need like terms when we're going to start doing polynomials. We need, yeah, I think that's it for now. Oh, like place values. So think about when you add 2 numbers. 572 plus 34. What do? You have to line up the place values, or if they're decimals, you line up the decimal points. And then add down. We'll add these 2. We can subtract them. We'll just add them. So 2 plus 4 is 6. 7 plus 3 is 10. Carry 1. We'd get 606. Yeah, you might not believe me. 572 plus 34, 606. I'm going to put a little check mark because I know it's right now. So with like place values, that's what I mean by like place values. We've got to line up the place values. You thought there was a bunch of rules? It's not a bunch of rules. It's the same thing over and over again. Line up the place values. Line up the place values, you might have heard, or line up the decimals. We line up the decimals, so we line up the place values. Decimal point. Okay, when we did fractions, we had to have like denominators. That took some getting used to. And when we look at polynomials, we'll need like terms. So addition and subtraction is very weak. Again, sometimes it's called combining. And we can look at subtraction as actually negative signs. So sometimes I flip back and forth and I use those over and over again. So let's take a look at some problems. Let's say negative 2 plus negative 7. Now, this is a little complicated. We will very soon get used to seeing it like this. Negative 2 minus 7. So what we have going on here is we've got a push and pull. Push, pull on the number line. And these negative numbers are direction. So this one is like magnitude of 2 in the negative direction, along or combined with a magnitude of 7 in the negative direction, actually gets us something that's more negative. If I did 5 plus 4, it's the same idea. 5, this is automatically positive direction, combined with a 4 in the positive direction. Oh, I didn't realize they'd be the same magnitude. That's also a 9. Well, this was a negative 9, that's a positive 9. So a negative 2 combined with a negative 7 gets more negative with a negative 9. Positive 5 combined with a positive 4 gets more positive with a 9. But what happens if we have negative 2 plus 5? Or if we have 4 plus negative 7? I'll put that in parentheses. So what do we got going on here? Well, we've got a 5. We've got a 5 in the positive direction and a 2 in the negative direction. They actually offset each other. So this is actually the same as 5 minus 2, which is 3. What did I just do? I switched these. This is a negative 2 and this is a positive 5. I can add in any order. Don't think of this as subtraction. Think of it as adding a negative 2 or combining a negative 2. So this problem here, I don't like these parentheses. That's why I'm leaving myself some room. I have 4 in the positive direction, and then I go 7 in the negative direction. Who wins this? Which one's larger? Which one's heavier? The 7 is heavier. So he wins. By how much? By a value of 3. By a value of 3. So this is a negative 3. So it's a push and a pull. Goes back and forth. You can think of it as the number line. This is where you start and you move 7 in the negative direction. This is where you start and you move 4 in the positive direction. This is where you start and you move 5 in the positive direction. You end up on the positive side because 5 was heavier. So there is a rule for this. There is a rule. I'm going to give it to you. If you have the same sign, rule for addition. If you have the same sign, actually we're only adding 2 numbers, 2 real numbers. If you have the same sign, Well, you combine I don't like the rule. Add absolute values, because that's just adding two positive numbers. And the sum, that's when you add, it's called a sum, has the same sign. When you have different signs, you're actually going to subtract the smaller absolute value from the larger absolute value, and the sum has the sign of the number, this is horrible, with the larger absolute value. Okay, you can remember that, or you could think about the push and pull and who's winning and a tug of war, and the negatives and the positives are directions. But again, or you could read the chapter. This is actually on chapter 13, this rule. Okay, I want to start getting rid of. So let's do negative 1.1 minus 1.2. Well, they're the same sign. So basically the answer is negative. Let's think about that first. The answer is negative because they have the same sign. And we're going to combine 1.1 and 1.2, which is their absolute values, which is 2.3. The answer to this is negative 2.3. Yeah, I don't like that. Well, what about, let's see. Let's just take a look at some, well, negative 17 plus 5. So let's just take a look. These have different signs. So subtract the small absolute value from larger absolute value. This is 17, is its absolute value, and this is 5. And I'm going to subtract them, and I get 12. And the sign of the larger, this one's larger, the sign of the larger is negative. So the answer is negative 12. You've got to be thinking all this in your head in order to get that. I'm not crazy about how that's written. So let's subtract. Rules for subtraction. Rule for subtraction. Basically comes to, we'll put it in symbols. A minus B becomes A plus negative B. So to subtract B from A, add the opposite of B to A. To subtract B from a number, A, add the opposite of B to A. This is easier to see for me. This is a positive A and a negative B, and then you add them, a positive A and a negative B. You combine them. So let's take a look at some examples, because I want you to simplify. Or, no, you know what? Clear the clutter. I want you to clear the clutter when you do these. So 9 minus 12, negative 7 minus 2, negative 8 minus negative 2, 12 minus negative 5. Okay, 9 minus 12 is a positive 9 and a negative 12. Who wins the tug of war? The negative one does, by 3. Both negative. Negative 7 combined with a negative 2 is a negative 9. Negative 7, and then you combine a negative 2. This one, this is what I mean by clearing the clutter. Instead of subtracting negative 2, rewrite this as plus 2. The opposite of a negative 2 is a positive 2. Instead of subtracting negative 2, you're going to add 2. The negative 8 stays the same. Okay, you might have seen this as keep, change, 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 change. I didn't like that either. This is a negative 6. I think that's much clearer. Negative 8 and then add a 2. So I take it off. So I'm less negative, if you think of it that way. This one, rewrite it as 12 plus 5. That makes that so much clearer, and that's 17. That's how you subtract. Which brings us to multiplying. Multiplying real numbers. Now, I wanted to go back and I told you level 2. So we're on level 2. Level 2 is multiplication, and division. Multiplication and division. So when we're multiplying and dividing, when it comes to the signs, we have for both multiplication and division, we have even number of negative signs or odd number of negative signs. Okay, even number of negative signs, the product, which is what we call a multiplication problem. The answer to a multiplication problem is positive, and for an odd number of negative signs, the product is negative. Yep. That's it. Why? Well, we just saw that, right? The negative of negative b is actually just b. That's why. It's like a double opposite. The opposite of a number is the same as multiplying by -1. Wow, that's powerful. The opposite of a number is the same as multiplying by -1 because it's on the opposite side of 0. So when you multiply by -1, you flip over the 0. So let's take a look at some examples, and then we'll take a look at okay, so this has only one sign, so the answer to this is -21. The answer to this is positive. I don't have to write the positive, but I need to remember that. And then 3 times 9 is 27. That's it. And 5 times -2, the answer is negative, and 5 times 2 is 10. So let me just point out know your multiplication tables from 0 all the way up to 12. You need that for this class. Use flashcards. Do an online games. Whatever you need to do. Get up to speed. ASAP. Get up to speed ASAP. I don't know if I can really highlight that. Enough. Okay, so let's multiply. Let's just look at a fraction refresher. So if I want to multiply negative 4/7 and negative 14/3, first off, the answer is positive. Negative times negative is a positive. Two signs, product is positive. So the answer is going to be 4/7 times 14/3. How do you multiply fractions? Well, you multiply across the top and multiply across the bottom. So the top is going to be 4 times 14. The bottom is going to be 7 times 3. At this point, you can recognize that 7 goes into 14 evenly, right? Or we can actually factor 14 into 2 times 7. So what I did is I took the 14 and I factored into 2 times 7. And this is 7 times 3. So what's going on here is I have a factor of 7 in the numerator on top and in the denominator on the bottom. They cancel because 7/7 is equal to 1. And when we multiply by 1, we don't change the number. So 1 is actually the multiplicative identity, because any number times 1 equals that number back again. So what do we have here? So we've got 4 times 2 in the numerator and 3 in the denominator, which is 8/3. And I could just go back, double check. The answer is positive. So that's the answer to that question. I can leave it like that. You don't have to change it. We're okay. That's called an improper fraction. They're okay. There is nothing improper. About improper fractions. There's nothing improper about improper fractions. So let's talk about reciprocals. Well, that's a fraction refresher. Do you need a decimal refresher? Oh, I'll give you one. There's a decimal refresher for multiplying numbers. So let's take negative 0.05 and 0.006. Oi. Well, let's just write down here. What's the sign of the answer? The answer is negative. Make yourself a little note if you have to, because sometimes you get so busy with the details you can't figure it out. Well, I'm going to convert these to fractions and show you what's going on. This is 5/100. I'll just keep the negative there for now. And this one is 6/1000. Two place values, 2 zeros in the denominator, 3 place values, 3 zeros in the denominator. Well, the answer is negative. 5 times 6 on the top. I don't know why I used the dot there. And 100 times 1,000. If you don't believe me, 5 times 6 is 30. And 100, 2 zeros, times 1,000, 3 zeros, is 1, 2, 3, 4, 5. Has 5 zeros, 100,000. 100 times 1, 1, 2, 3, 1,000 is 100,000. So I need to have a 30 with 5 decimal places. 1, 2, 3, 4, 5. Put the decimal here, fill in, and rewrite. I got to bring down that negative sign. Negative 0.0003. Okay, I will show you. Negative 0.05 times 0.006 equals. What does that say? I'm glad we came into this. This is exponential notation. This is the number negative 3 with 4 place values. Negative 3 with 4 place values. So here's your 3, your negative 3, and you go 1, 2, 3, 4. This is what I want to see. I don't want you to become dependent on the calculator. That's why you're having trouble now. If you're having trouble now. Stay away from the calculator. Understand the rules. There's your decimal refresher. That's the answer to the problem. Negative 0.0003. Okay? So that's multiplication, fractions, decimals, and let's talk about, before we get into division, let's talk about the reciprocal of a number. So basically, it's a flip, reciprocal. So if I have A over B, if you're given A over B, the reciprocal is B over A. Examples. Let's give me a number, and it's reciprocal. You need to know the number before you talk about a reciprocal. So, 5 over 7. Its reciprocal is 7 over 5. Well, what about negative 2 over 3? What's its reciprocal? That is 2 over, 3 over negative 2, or negative 3 over 2. It's still negative. I'll write that down. It's still negative. You didn't change its sign. You just changed the numerator and the denominator. Well, what about negative 2? Well, you got to recognize that negative 2 is negative 2 over 1. So its reciprocal is negative 1 over 2. So this actually has a denominator of 1. I mentioned that integers have a denominator of 1. So when I flip it, the 1 becomes on the top, and the 2 becomes on the bottom. The multiplicative inverse of a number is its reciprocal. So I've got multiplication, I've got multiplication and inverse, undo, oh, I forgot where, I think I did it on chapter R.1 when I said addition. I was trying to match it, but the multiplicative inverse of a number is its reciprocal. So a number times its reciprocal is going to equal 1. And what did I say 1 was? That's the multiplicative identity. So when I have a number, I multiply by its reciprocal, I get back to the identity. That's what an inverse is. Undoes that number to get back to the identity based on the operation that you're using. Here we're using multiplication. So that's a multiplicative inverse property. And I also mentioned the multiplicative identity property, which is a times 1 equals 1. And we could do this with any number. Let's just take a look. Well, let's look at our examples here. Does 5/7 times 7/5, does that equal 1? 5 times 7 over 7 times 5. 5 and 5 cancel, 7 and 7 cancel. You end up with not 0, 1 over 1, which is just 1. What about negative 2/3 times negative 3/2? Well, the answer is positive. 6 over 6, which is, which is 1. That one's right. And of course, negative 2 times its reciprocal equals 1. So these all work. These all work. So when we divide, we're going to change that to multiply by the reciprocal. So division is multiplying by the reciprocal. How do we write that? A divided by B equals A times 1 over B. Now, silly me, but if you continue this on, A times 1 over B is A times 1 over 1 times B. A times itself is just itself. A times 1 is just A, and 1 times B is just B. And if you notice, that is another way to write A divided by B. So this is consistent. It's at least consistent. Let's see, question. 6 divided by 0 versus 0 divided by 6. What is this? Well, this one is undefined. And this one equals 0. So this one you could think of as a number over 0. No. This one, 0 over n, 0 over number equals 0. You're on. So be really careful with zeros. Whether they're in the numerator or the denominator, it's two same things. So if division is multiplying by the reciprocal, it has exactly the same sign rules as multiplication. That is, when I have an even number of negative signs, the product is negative. When I have an odd number of negative signs, the product is negative. When I have an even number of negative signs, the product is positive. When I have an odd number of negative signs, the product is negative. I wasn't sure where I said that. So let's start dividing. Well, let's start easy. Let's start with integers. Negative 12 divided by 4. What the answer is negative. And we can think of this as 4 times 3 in the numerator and 4 in the denominator, and this is going to reduce to negative 3 because 4 over 4 reduces to 1. 4 over 4 reduces to 1. And 1 times 3 is just 3. Don't forget the negative sign. Always go back and look. That's the easiest way to do it. Let's try negative 9/14 divided by 3/7. Well, what we're going to do is we're going to do a little flip. Keep, flip, whoop, keep, change, flip. So I'm not crazy about that, but we're going to change this to multiplication, and instead of 3 over 7, because we changed the operation, we're going to do 7 over 3. So when we look at that, the answer is going to be negative. And I hope you can kind of see, sometimes we'll do a simplified like this, but be very careful. You don't want to lose what you're doing. These canceled out. Those are just ones. I don't usually write the 1 because I don't like to have a lot of clutter. So in the numerator, I have a 3. Don't forget the answer is negative. And in the denominator, I have a 2. So that problem ended up being negative 3 over 2. Let's see what else. How about this one? This one looks good. 3 over 8 divided by negative 11 over 16. So this big fraction bar you can recognize as division. So this is equivalent to 3 over 8 divided by negative 11 over 16. And then if we flip it, 3 over 8 times 16 over 11. Don't forget that negative sign. The answer is negative. I recognize 16 and 8 as going into each other. I've got a negative 6 on the top and 11 on the bottom because all I did was multiply across the top, multiply across the bottom. I said that backwards. This one is negative 6 over 11. Hope that makes things easier for you. That's the end of R.2.